Consider now the limit f of x minus g of x as x approaches a, and suppose initial substitution gives infinity minus infinity. And another case wherein you have limit of f of x times g of x as x approaches to a, and suppose initial substitution gives you 0 multiplied by infinity. Take note, L'Hopital's rule only works for 0 over 0 or infinity over infinity. Now, in this second episode on the L'Hopital's rule, we are going to evaluate limits involving indeterminate form infinity minus infinity, and at the same time we are going to evaluate limits involving the indeterminate form 0 multiplied by infinity. Now, recalling the 7 indeterminate forms, this episode we are taking infinity minus infinity and 0 multiplied by infinity. Infinity minus infinity has 4 different forms. Positive infinity minus positive infinity, positive infinity plus minus infinity, minus infinity minus minus infinity, minus infinity plus positive infinity. Now, in this case, these 3 forms can actually be written into the first form. What we see here is one term is pushing it towards the positive side, and the other one is pulling it on the other side, on the negative side. So in effect, you don't know where the limit is going. This is the case of the indeterminate form infinity minus infinity. The other 4 cases are okay because here one term is going to the positive infinity, the other is also going to the positive infinity, and both are going on the same direction. So this is not an indeterminate form. The second one is also not in an indeterminate form. The third one is just similar to the first one, and the last one is just similar to the second one. So what we are going to consider infinity minus infinity indeterminate forms are only these 4 possible forms. So how are we going to evaluate limits wherein we have infinity minus infinity? Basically, our given function is this, f of x plus or minus g of x, and we are taking its limit as x approaches a, and suppose that initial substitutions give you actually either one of these forms. So what are we going to do is to combine the terms of the function f plus g of x or f minus g of x, or we can manipulate it to give an indeterminate form 0 over 0 or infinity over infinity. And after that, that's the time we can apply L'Hopital's rule. Let's take an example. Suppose we are asked to find the limit of 1 over x minus 1 over sine x as x approaches 0 from the right. Now, f of x here is just 1 over x, and the g of x is actually 1 over sine x. Note that as x goes to 0, the f of x here, 1 over x, will just go to positive infinity. And as the x also goes to 0 from the right, sine of x is going to 0, so 1 over a very small positive number will be actually going to positive infinity. So this is a positive infinity minus a positive infinity case. So what we are going to do is to first rewrite our limit as x approaches 0 from the right. We can actually use this rule, a over b minus c over d. Okay, all we have to do is to multiply a and d, then minus, multiply b and c, and then afterwards we multiply b and d. So in here we have sine x times 1 will be sine x minus x times 1, that will be x, divided by x times sine x, that will be x sine x. And then let's evaluate now this limit. So take note, if I'm going to do direct substitution, this will now give me sine 0 minus 0 over 0 times sine of 0. and this will be actually a 0 over 0. Now this time we can now apply the L'Hopital's rule. The L'Hopital's rule says we have to take the derivative of the numerator, and then you take the derivative of the denominator, and afterwards we take the limit as x approaches 0 from the right. Rewriting this one, we will have limit as x approaches 0 from the right. Well, derivative of sine x is just cosine x. Derivative of x is just 1. So I have cosine x minus 1 in my numerator. For the denominator x sine x, note that this is in the form u multiplied by v. Then you're taking the derivative. So all you have to do is to take the derivative of the u, multiply it to v, plus copy the u and then multiply it by the derivative of v. So doing it here for x sine x, we will have derivative of x is just 1 times sine x. So this will be sine x plus copy the x, and then derivative of sine x is cosine x. Let's try to evaluate this limit again. So if I'm going to substitute 0 in the variable x, so cosine of 0 is 1 minus 1, so my numerator will be 0. And sine x is 0. 0 multiplied by cosine x will be 0, so the denominator will also be 0. Again, this is an indeterminate form, 0 over 0. So in this case, we will have to apply the L'Hopital's rule another time. So the L'Hopital's rule says I'll take the derivative of cosine x minus 1, take the derivative of the numerator, and then I will also take the derivative of the denominator. Afterwards, I will take the limit as x approaches 0 from the right. So let's simplify this one. So limit as x approaches 0 from the right. The numerator now will be derivative of cosine x is minus sine x. Derivative of minus 1 is just 0. Divided by derivative of sine x is just cosine x. Plus, now take note here, for x cosine x, we have to apply another product rule. So I'll take the derivative of x, which is just 1, multiplied by cosine. So I have cosine x, plus I'll copy x and then take the derivative of cosine x. That will be minus sine x. So ultimately, I can rewrite this as limit as x approaches 0 from the right minus sine x divided by 2 cosine x minus x sine x. Let's evaluate the limit now. If I'm going to do direct substitution by replacing the variable x by 0, so this will be minus sine of 0 divided by 2 cosine of 0 minus 0 times sine of 0. Well, sine of 0 will just be 0. 2 cosine of 0, this will be 2. 0 times sine 0 is just 0, so the denominator will just be 2, but the net effect will just be 0. And that is our final answer. Now, for the second case, suppose now we have limit of f of x multiplied by g of x, and suppose that after initial substitution you get a 0 multiplied by infinity. How are you going to evaluate such limit? So first, we have to rewrite our function f of x multiplied by g of x as f of x divided by 1 over g of x, or you can keep the g of x up but divide it by 1 over f of x. Now doing this, you will now have either a 0 over 0 or infinity over infinity. So the next step now is just to apply L'Hopital's rule to the new written function. Let's take an example. Suppose I have limit of x multiplied by sine pi over x as x approaches positive infinity. Take note here that as x goes to positive infinity, pi divided by x will go to 0. And this means that sine of pi over x will go to 0. So in a way, our form now will be x goes to positive infinity, while sine of pi over x will go to 0. This is an indeterminate form, 0 multiplied by positive infinity. Our goal here is to rewrite this function. I just copy limit as x approaches positive infinity. I will keep the sine pi over x up in the numerator, but I have to divide this by 1 over x. Now, in this case, the numerator goes to 0. The denominator will also go to 0. So this is now a 0 over 0 indeterminate form. So I can apply L'Hopital's rule. So the L'Hopital's rule says I will take the derivative of my numerator divided by the derivative of the denominator, and after taking these derivatives, I will take now the limit as x approaches positive infinity. Simplifying this, we'll have limit as x approaches positive infinity. Well, in here we are going to use the chain rule. First, we take the derivative of sine, which is cosine. I'll copy the angle, multiplied by the derivative of the angle. But what is the derivative of that angle? Pi over x, take the derivative, divided by, well, the derivative of 1 over x is just minus 1 over x squared. Now, actually, pi over x can be written as pi 1 over x. Well, the derivative now of this one is just taking the derivative of 1 over x. So its derivative now will just be pi times minus 1 over x squared. So I can actually rewrite this simply as this one, pi times minus 1 over x squared. So I can cancel these two, my numerator and denominator, and I will now have limit as x approaches positive infinity of cosine pi over x multiplied by pi. Now, let's consider this limit now. Actually, I can move the pi outside of the limit and we'll just have limit as x approaches positive infinity of cosine pi over x. And take note, again here, as x goes to positive infinity, pi over x goes to 0. And that means cosine of pi over x will go to 1. So this limit will just go to 1. So 1 multiplied by pi will just be pi. That's our final answer.